Hello. I'm just recovering from a bit of minor surgery on my hand, so I can't really do much in terms of heavy lifting or intricate things. So I figured I'd show this little project thing I put together a few weeks ago that has actually come in pretty handy, and I just wanted to show this in case anyone else wanted to do something similar. If you've ever watched videos I put on here in the past, if I need a test pattern, say for resolution or to test linearity or convergence or whatever, I have a DVD called Avia Home Theater, or Guide to Home Theater, that I bought some 20 odd years ago, that I just put in a DVD player and then just connect to whatever device I'm testing. And it's worked well enough. It's got good test patterns on there. It gets the job done. But using a DVD player kind of sucks. It's annoying. You have to use the remote. You have to go through the menus, and DVD menus are slow and laggy. You have to hit pause on the patterns because they only last, I think, like a minute before they go back to the main menu. So I wanted something better. But test pattern generators are not very common around here where I live. And I didn't really feel like spending $100+ Canadian shipping one here just to have to repair it and fix it up. The one test pattern generator I did find here is this delightfully 1960s RCA all-tube test pattern generator that I think I showed in a video a while back. It's got like 20 some odd tubes in it. It gets very warm, but it has issues. It's got waviness, it's got interference, beat patterns on the screen, and despite getting the service manual and calibrating it to the best of my ability, also recapping the whole thing, it just kind of sucks. It's just old. So I put this together. This is the VeryGood-91 Pattern Gener ator. It's a Raspberry Pi first generation, so a Pi 1B, with a 4 gig memory card, full-size SD, in one of those original acrylic cases that they used to come with back when these things were truly $20. And I had this kicking around as the old school Composite RCA video output that I think every generation afterwards put that into a TRRS jack and combined it with audio. These are switches that I salvaged off an old board from I think it was a spare board from a JVC VCR in the scrap bin. Some wires going off to the GPIO pins on here, and it just glued it there, used the label maker to label the buttons. You know, I think it shows a nice janky project. But what does it do? Well, let's boot this up and I'll show you. So as you can see, it's booting Linux. It's booting Raspberry Pi OS Lite, formerly known as Raspbian. I think they changed what Linux it's based off of and renamed it. And it will take a long time to boot on this old slow-ass Pi. So yeah, for this slow boot and some other reasons I'll explain later, I really recommend using a newer Pi, like a second generation or third generation. You can still find them for pretty cheap now that the sort of peak pandemic pricing has petered off a little bit. But yeah, let's look and see what this does. So right now it's on a single color raster. It defaults to the first pattern on here, which is red. And I can cycle through. This is yellow. The camera changes it to gray. I don't know, it thinks it's too smart. It's not a white balance thing. Trust me, it's yellow. This is more of a bright lime pure green, not this forest green. That's cyan, that's blue, that's magenta, and this is sort of a light gray, almost white. And then if I go here, I can get the SMPTE color bars, or just full color bars top to bottom. I can also get some vertical grayscale or horizontal grayscale bars. And move on to the next one here, which is crosshatch. So for things like convergence and linearity, I got the crosshatch, circle hatch, this weird rectangular thing, dot hatch, just the dots. Could turn the dots into pluses. I don't know why I put this on here. And my favorite, and I have no idea what this would be used for, checkerboard. And the last video pattern button on here is for checking the resolution. So I go through, these I've shown on here before when I'm testing resolution on VCRs. This is a 200 TVL test pattern, 100 TVL. This is bandwidth. So how much bandwidth the horizontal has is essentially like a TVL kind of test, except let's see, it shows the bandwidth in megahertz. Now on a lot of cheaper TVs, actually most CRT TVs, you'll see color fringing on like the 3.58, because I think that's the frequency for the color burst, if I'm not mistaken, and all the way up to 5 megahertz, which you'll notice this TV is doing an excellent job of. Like, look at that. That's really good for a composite video signal. At any rate, we've got that. I think that's a pretty neat test pattern. That's an old school American TV test pattern. And then I got this sharpness one, which I'm not really sure what it's used for, but I put it on here anyway, because I can put any image that I want. And then the last one is a 1 kilohertz sine wave that sounds a little dirty coming out of these speakers. I know I had some problems getting it to generate a nice clean sine wave, and I think I might have to increase the buffer size. I'll show more of that when I show the actual code that was put together to make this work. And now here it is running on this pretty crappy Philips Magnavox cheap color 5-inch portable TV that has a horrendous whine. There's a component in there, maybe the flyback, that is just noisy. I might remember to filter this, and if I don't, I'm sorry. But yeah, if we look at it here, oh, that's a nice red. The camera's still turning that gray. Green, blue, or cyan, blue, magenta. Nice color bars. I think the tint needs to be adjusted on this. This is more of a fuchsia in real life. It needs to be adjusted. And the grayscale, this does have a nice grayscale. And the resolution, oh my god. Horrible. There, I got you zoomed in as best I could. This is not a very good TV. It's just a cheap portable. Even 100 TVL is pretty bad. And here's an example of the color fringing I was talking about. So this one actually starts to fail. Let's get the numbers on here. Right at 3 megahertz. 2 megahertz is visible. Everything afterwards just turns into color noise and then just disappears. So, perfect example of testing a TV with this old device. That looks kind of nice though. And of course, if I want to use my little tester on a TV without a composite video input, I can just go and use an Agile Modulator, like this Holland HMI 860H that I got a while back. So this will do pretty much every VHF channel, and then I believe it does, cable frequencies. I'll go a little higher than I remember. Most TVs and VCRs that I remember from the 90s went up to 125. This will go a little further, up to 135. At any rate, works perfectly fine on this TV. Go and turn the sound on. I guess that's more yellow than it looked on the others. See, it's this yellow here, which in the context of the color bars, you can see it's yellow. But looks fine. Camera's not really picking it up very well, but you can just make out the detail down here. And yeah, if I put this test pattern on, I get a very interesting phenomenon where each of these lines is only one line, right? So I'm seeing a flicker go on because these lines are only present in one field of video because of the interlacing. And you're actually seeing that go here. This is not a progressive signal, so you're seeing the bars slowly roll up here. But what I'm seeing in person is a very violent flickering. Okay, so I went and set my camera to 1/60th shutter speed in order to show the flickering, but since I'm using DaVinci Resolve and I have my project set to 30 frames per second, it's kind of an ordeal to change it. So I just slowed it down by 1/8. So we're seeing this at 1/8 speed, and you can see the horizontal lines flashing. The reason why the whole screen's not flashing together and you'll see a separation slowly peel down is because the TV's vertical refresh and the camera's vertical starting point are not in sync. They're both running separately. The camera is recording at 60 frames per second with a 1/60th shutter speed, but the TV is running at 59.94 fields per second because it's NTSC, which is complicated and I'm not going to get into it, but just trust me, that's why. And of course, if we go to resolution, you'll see that yeah, not the best resolution on this TV. Actually, pretty poor when you get into the color banding here. Let's see. Yeah, not great. I mean, it's RF. It's kind of what you'd expect from a standard RF tuner. 3 megahertz shows up fine. 3.58 falls to the color rainbow, which is not as... Oh, there it is, yeah. It's quite present, going from red to blue here. Yeah, like that. Which is funny because those are the colors that you got on an Apple II using this effect here. Alright, and here's a quick look at the Python script that runs all this. I'm not a big expert on it, so I'm just going to kind of show the code here. This was all borrowed from other websites, people showing how to do things. I used the GPIO for interfacing with the GPIO pins. I used Pygame for displaying the images, and then I used PyAudio and NumPy or NumPy for doing the sine wave for the audio. So I'm kind of showing the breakdown here on the right hand side. Blue is for the GPIO, green is for video, and then red is for the audio. So here's all the images for the different buttons. I just segmented them into 10s, 20s, 30s, and 40s for button 1, 2, 3, and 4. And then each one of these is a callback for the button. This is button 1, and then I just set the range of the images, and then it just goes through them. These globals are because I probably could have just passed these variables out of the callback, but I didn't bother looking up how to do that, so they're globals. One is the screen value, which is what I use to address this array, and then the other is change, which I set to active if a button's been pressed, and I've actually made a change here, which is used further down. So these are all the button callbacks. Button 5 is for the audio, so that just toggles the audio on and off. And then this is a callback that's running continuously for the audio. Don't ask me too much, I just found this code online. This is basically creating a sine wave and then outputting it to the audio. GPIO initialization, so these are the pins that were used. I just created an event in the background to check to see when the state changes. And then in this callback, it just uses a check to see if it's high as a debounce. Initialization for the video output. This is for the video, for displaying that. For buffer size, I don't think you need 4096. I had it set to 2048 and it was fine. But for whatever reason, the left channel has noise on it and the right channel doesn't. So I tried increasing the buffer size to see if that fixed it. It didn't. This actually brings me to the issues with the Pi 1. You could use Pygame for audio, but it didn't work for me. It was glitching out. Anytime it tried to address any of the hardware, I was getting weird errors. It was just a mess. I couldn't get it to work. I had to use PyAudio instead of Pygame. Another item here, I guess the latest version of GPIO doesn't natively support the Pi 1 or I think the original Pi 0 anymore. And that's because they had revision numbers that were only 4 digits, and then all the later Pis have revision numbers that are 6 digits. So the GPIO developers just no longer support the 4 digit. So you have to set this environmental variable, and then this number here is the revision that will identify this as a Pi 1B to the GPIO. And then I just added this line to bash.rc, which is one of many ways that you can launch something on boot. There's so many different ways you can launch it on boot. There's bash.rc. I believe I'm launching this in, I think it's local.rc. It occurs after everything else is done. It's the last thing to happen. And I had to do that because there's other stuff that has to boot beforehand. I tried cron tab, I tried all sorts of things, none of them worked. Local RC worked. At any rate, and then this is just opening the audio stream here, and then this is the loop that just keeps running in the background. So that change variable, if changed, then refresh the image, and then the audio, just, you know, check to see if it's changed and turn the stream on and off. This was supposed to be so I can use the keyboard to exit. It doesn't actually work. So yeah, just don't worry about this. Oh yeah, and the sleep function. I believe this is in seconds, so this would be running every 100 milliseconds, I believe. Anyway, I'm a Python / Linux noob. If I need to do something, I can Google it and get it done, but I do not make the nicest code, but it works. So yeah, that was it. Just wanted to show this little project off and what it does, and I'm hoping it's going to be useful to me, and maybe it was useful to you. Thank you for watching.